Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the surge divider and also the types of surge dividers which are used in our AC and DC substations. Then, how it's working, which means the working principle of this surge divider or lighting arrestor or surge arrestor. Then, practically how the in substation how the connections are being done for this surge divider or a lightning arrestor or surge arresters. First, in a power line, the surge dividers are parallelly connected with respect of earth or across the two insulator medium. The surge dividers may be connected in some of the connections. Then it consists of normally a spark gaps and a non-linear resistor, and total set is known as the lightning arrestor set. In as seen in the diagram, it is consist of a spark gap which is a series with a non-linear resistor. The length of the spark gap is set in such a way that normal system voltage is not sufficient to initiate an arc across the gap, while very high voltage will cause a breakdown in the air medium, which means the air insulation inside the gap, and initiate an arc, and then the arc will be fed to the earthing surface. As there is a breakdown of spark gap due to the over voltage, the arc could be short circuited on a system and cause a power flow current in a diverter. After the surge is over, the resistor offers a very high resistance to prevent effect of a short circuit, which makes a spark non-conductive. The arc in a gap should cause after a surge is over. The voltage drop across the arrestor should be less than the breakdown strength of your insulation to be protected. Then types of surge arrestors commonly used are valve type or gap silicon carbide surge arrestor, then zinc oxide gapless arrestors or metal oxide arrestors. These are the common types of surge arrestors used. Then metal oxide surge arrestor or zinc oxide surge arrestor. The arrestor uses a zinc oxide semiconductor at a resistor material. The arrestor provide a protection against all type of AC or and also for the DC over voltages. So the zinc oxide is a semiconducting material of a N-type, combination finely grinded, which means like a powdered condition. The more than 10 doping materials are added in the form of fine powders of insulating oxide, such as bismuth, antimony trioxide, cobalt oxide, manganese oxide, chromium oxide. So the powders are dry, compressed into a disc-shaped blocks. The blocks are retained in the sense sintered in the sense heated or even a melted condition, and then taking into a shape to obtain a sense polycrystal ceramics. Then the disc enclosed with the porcelain housings filled with a nitrogen gas or a SSX gas in order to uh, shrink the arc producing inside the medium. At a normal voltage, the potential barrier does not allow the current to flow through it. So whenever the breakdowns happens, the transition of current from insulating to a conducting state takes place. The current started flowing to the surge and diverted to the ground. So this is the basics of your metal oxide lightning arrestor or zinc oxide lightning arrestor. It consists of a semiconductor device, as I said. The zinc oxide elements are inside a conductive silicon rubber collisions and also been placed. Then the line terminals where you have to connect and the ground terminals where you have to connect are mentioned in the diagram. These are all the basics of your metal oxide lightning arrestor. Next, surge arrestor, surge absorber. In the sense, normally the arrestor, in the sense, it's commonly known as a diverter, which means it diverts the over voltage from a line to a ground for a particular time. After that, it will gets into a normal condition. If the condition exaggerated, or the time where the conduction takes place in a higher level, means in the sense the LA get blasted, or even a ground fault will be obtained. So in the sense, the LA, or that arrestor which we are using, should be having a time period for conducting. So now the surge absorber, in the sense, the normally the diverter diverts the surges to earth, but absorber absorbs the energy contained in the surges. So the stiffness of a wave front of a travel waves can damage the apparatus in addition to a magnitude of waves. So to reduce the stiffness of wave front of surges, or the surge arresters, which means the surge absorber, is used. Normally it consists of a capacitor connecting in a parallel with the transformer, or any protective devices, or even a series of resistor and capacitors will be connected in a line in a parallel condition to earth. So in the sense, the absorber absorbs the extra surges, or over voltage in the circuit. A capacitor connected between the line and the earth can reduce the stiffness of wave. So the impedance of a capacitor is inversely proportional to the frequency. It gives a protection against low voltage high frequency waves. Then the resistor and the inductor in the parallel combination. This combination is placed in a series with the line stepping waves front, or a high frequency discharge, to find a inductive path to have a reactance and forced resistor where they are dissipated. So these are all the common things, how the surge absorbers are working, and what and all the connections need to be done for surge arresters. Next, ratings of the lightning arrestor. The highest voltage of the system is normally taken as a 110% of the nominal voltage. So the coefficient of earthing is nothing but the highest RMS value, which means RMS voltage of a phase to earth divided by phase to phase normal RMS voltage. And for a effective earthed system, the voltage rating of a arrestor is equal to highest phase to phase RMS voltage into a coefficient of earthing. So the for a non-effective or isolated or a neutral unearthed system, the voltage rating of a arrestor is equal to 1.1 into phase to phase RMS voltage into coefficient of earthing. Here the for a effective earthed system, the coefficient of earthing is 0.8, which is a constant value for a effective earthed system. This is the formulas to find the rating of lightning arresters. Next, commonly used lightning arrestor and where they are used. Rod gap type, in the sense, in bushing insulators or support insulators, or across support strings in AC and DC systems, this rod gap type is used. Next, overhead overload earthing ground, which means overhead earthed ground wires, which means it will be used in your transmission lines. Next, vertical mods in a substation, commonly used substations will be using this vertical type. Next, earthed lightning rod in tall buildings, or even normally in IT buildings, or even in our home itself, this kind of lightning rods will be used. Then lightning or surge arrestor. This is the commonly used lightning arrestor, which are used in your AC or DC substations. You can refer my last of my videos for practical knowledge of how the connections are being done. Then the surge absorbers, it is used in your rotating machines or switchgear series reactors, such as this surge absorbers will be used. Next, this is the normal connection of a lightning arrestor in your switchgear 33 kV system. Here the lightning arrestor is connected in a parallel with your earth. Then this is your DC yard, HVDC yard, neutral bus lightning arrestor. This is the in the top you can see the neutral bus is connected with the lightning arrestor, and the lightning arrestor is further moved to your surge monitor. Then the surge by the surge monitor there will be some of the indicating device will be connected and moved to your ear. This is another type of lightning arrestor or a surge arrestor connected with your DC bus system, which means HVDC system. This is also the same thing. The bus is at the top and it is connected, the LA is connected in parallel with the bus, and then further is moved to your indicating or monitoring system and earth. This is your HVDC, which means the line, main line, HVDC line, bus connections of LA. In here the LAs are separated by each stack, and all the stacks will be connected in series and forms a complete LA system, which means this type of LA is a zinc oxide. HVDC in the sense the voltage will be in a higher rating only, so only we are using this semiconductor type of or a metal oxide type of the LA systems. Here you can easily able to see at the bottom there is a spring which is connecting with the total set, and the spring tensions will be there. According to their tension the voltage get drifted. Then the all the stacks will be connected in series, and then one line which means the one cable will be connected with your indicating or a monitoring system, which means the surge monitors. And then further with the connection of surge monitor there will be some of the earthing will be provided, and by the earthing the leakage current will be flows to the ground. Hope you understand the basics of your surge arresters and lightning arresters or surge absorbers. Keep sharing my videos, share your knowledge and gain your knowledge. Thanks everyone. Nandri, vanakkam.